Hello everyone. In this video, we will introduce the binomial coefficients. This is a quantity that we will use a lot in this course. So it's very good to learn here and use it from this point on. And then we'll do some examples and then we will also study their properties. Okay, let me start with the definition here. So if you give me two numbers for any two non-negative integers n and k, such that k is a less than n. So if you have two numbers, which one is less than the other one, we introduce this notation. So we put a long bracket, put n up, k down. The way we read it as n choose k. That's how we read it. So n choose k. What is this? So this is just a notation. I have to tell you what is the value of this. This is a number. How do we find it? The upper one is n factorial up there. Then in the denominator, you have n minus k factorial and then k factorial. Okay? So this way, you have a quantity, n factorial, you compute it, divided by n minus k factorial, and then divide. So this guys, n choose k, are called, or is called binomial coefficient. The reason for the naming comes from another mathematical facts that when you expand a plus b to the power n, these are the coefficients that will show up there. Okay, so let's see some examples. For example, what is 12 choose 8? Okay, that means 12 factorial divided by 12 minus 8 factorial. Then another one, 8 itself factorial. Okay, so in other words, this is 12 factorial, 4 factorial, 8 factorial. We can simplify that. You see that 12 factorial has 8 factorial as a factor. So this is 12 times 11 times 10 times 9 times 8 factorial. Then this is 8 factorial. This is 4 factorial here. Then you can cancel that with that. What is 4 factorial? 4 factorial itself is 24. Actually, then you can cancel 12 with that. There will be 2 there. And then that 2 with that, and you get 5 there. So this way, basically, we have 11 times 5 times 9, which is 45. Then I guess this will be the number. Yes, 495. What is 7 choose 5? So 7 factorial divided by 7 minus 5 factorial and another 5 factorial in the denominator. This is 7 factorial, 2 factorial, 5 factorial. And 7 factorial, you have 5 factorial as the coefficient there, as a factor there. So 7 times 6 times 5 factorial. 2 factorial is just 2, and then 5 factorial there. Now I can cancel 5 factorial with that. This with that will give me 3, and then you get 21. What is 100 choose 100? So this is 100 factorial divided by 100 minus 100 factorial, and then 100 factorial, yes? So here right away you see that, okay, this is 100 factorial, 0 factorial, 100 factorial. Well, these two cancel each other and you get 1 over 0 factorial. 0 factorial is defined to be 1, so we have. How about 5 choose 1? So this is 5 factorial divided by 5 minus 1 factorial, then 1 factorial. So this is 5 factorial divided by 4 factorial, 1 factorial. And this I can write 5 times 4 factorial divided by 4 factorial. 1 factorial is 1. I don't need to write it again. So this 2 cancels, and what I will get is equal to 5. How about 8 choose 0? Yes, I can have choose 0. So 8 factorial minus 8 minus 0 factorial, and then 0 factorial. This is 8 factorial divided by 8 factorial, 0 factorial. So this way 8 factorial cancels with 8 factorial. And okay, I'm writing this to emphasize that you have to know that 0 factorial is 1. So that's why you get 1. And well, let's do one more. 10 factorial, 10 choose 6. And 10 factorial, 4 factorial. Here, then I have 6 factorial. 10 I can write as 10 times 9 times 8 times 7 times 6 factorial divided by 6 factorial, 4 factorial. Yes. So this way I can cancel 6 factorials. And then I write again this thing, open up 4 factorial. So 10 times 9 times 8 times 7, 4 times 3 times 2 times 1. Yes. So 8 cancels with these two. 3, we get 3 there. There's nothing left in the denominator. Yes. Then this is 210. 7 times 3 times 10 is 210. Okay, so these were some examples, but there are good properties that will help us in doing computing this binomial coefficients. Well, for example, if you have n choose n, what does it mean? It means that, okay, so n choose n is m factorial over n minus n factorial, and then n factorial. So this is m factorial divided by 0 factorial, m factorial. You see that m factorial cancels with that, and 0 factorial is 1, so we get 1. So for any n, positive integer n, n choose n is 1. N choose 0 has kind of same property, because you have m factorial over n minus 0 factorial and then 0 factorial. Yes, so this will give me m factorial divided by m factorial, 0 factorial, and then you cancel m factorials, and 0 factorial is 1, so this is also 1. There's one more thing that you can see always, that n choose 1 is, well, let's compute n factorial over n minus 1 factorial, 1 factorial. But n factorial over, for 1 factorial is just 1, yes? n factorial, we can write it as n times n minus 1 factorial, then divided by n minus 1 factorial. This way you can cancel these two. The final thing that we will have is n. That's n. N choose 1. For any positive integer, n is 1. Yeah, is n. Well, there's also another property that if you choose n choose k, well, see, n choose k is by definition is this guy, yes? But then I can write also n, choose n minus k. What does n choose n minus k? N factorial, n minus k factorial. This is the definition of binomial coefficient. And then n minus k factorial. I'll go backward just to show you what's happening. Here is k factorial. So what we have is basically n factorial divided by k factorial n minus k factorial. This says that n choose k is always equal to n choose n minus k. And, well, those are the properties. We will come back to these properties later when we learn more about binomial coefficients. And we will prove them in different ways. Okay, so you have to know the binomial coefficients and you have to be able to evaluate these things and know the properties.